going to do a few intro slides here, and then we'll get into our speakers. I want to just remind people this event is part of our UC Davis Sustainable Campus, Sustainable Cities initiative, which we launched last year, and we are working on a carbon neutral campus by 2025, but we also want to serve as a model for other campuses and cities in terms of sustainable operations. So we want to use the city scale campus that we have here as a living lab for solutions and collaboration. We also like to talk about it in terms of these 4 areas, and we are making progress in terms of toward carbon neutrality with on-campus projects, engaging also with other campuses as they're doing the same. And many of these projects also serve as research opportunities, and which we then also can turn into education opportunities with our project-based learning classes and our energy graduate group on campus. And we are trying to make an impact globally through these workshops. So we hosted one last year, our first one in person, and we're going virtual this year, but have a great turnout, and we're really glad to have you all here. So let's see, the sessions today, if you haven't seen, we're on this 3rd one. We've got a lunch with Energy Rockstars, so I want to encourage you to sign up for that one if you haven't yet. The link is there. Go to the website for this workshop and you can register. And it's not too late. There's a couple afternoon sessions as well, one on education and then some of the research and projects going on our UC Davis campus. So today's session will be, I'm Josh Morejohn moderating. I'm the energy manager here at UC Davis, and we have a great lineup of speakers. We're going to start with Arash, Guity, and Dan Mendonsa. They are going to speak on the decarbonization plan for the UC Davis Health, which is our medical center campus in Sacramento. Then we're going to hear from Rolf Schreiber, who is the energy strategy program manager at Google. And then John Elliott and Raphael Vitti are going to speak about their work at the Berkeley lab. So I want to remind you, you can go to the website for the workshop to see detailed speaker bios for each of our speakers. And the format is going to be, they're just going to give a brief presentation to spark some interest, tell you a little bit about what they're doing, and then we're going to save some time for your questions and some discussion at the end. So you all should be able to see a little questions section in your GoToWebinar control panel, and you can type questions there. We'll collect those, and at the end we'll try to get to as many as we can. Can be for any of the speakers. The sessions are being recorded, and then when you exit the session at the end, you'll get just a brief website. That'll be a survey, so we can get some feedback from you and keep improving our workshop as we go. If you have any issues, do reach out to the organizers. Their emails are there, or you can do it through the questions as well. Okay, with that, I'm going to turn it over to Arash and Dan for UC Davis Health.
Great. Thanks so much, Josh. Really appreciate it. Thank you all for joining us today. Today, we're going to be talking about UC Davis Health journey towards decarbonization, joined by my colleague, Dan Mendonsa from UC Davis Health, Energy Manager. So we're going to be telling a little bit about the background and the story to kind of prompt some questions and discussion later on in the session. So let me get this going here. So, you know, clearly we all understand the imperative of why we're concerned about decarbonization and electrification. In 2013, the University of California Office of the President, Janet Napolitano, created the Carbon Neutrality Initiative, which created an ambitious goal, and that was in 2013, created an ambitious goal of achieving carbon neutrality by the year 2025. And certainly that it creates some really interesting issues and challenges for healthcare, academic healthcare universities in particular. So we're going to be talking a little bit about the specific challenges that UC Davis Health has taken and how they've addressed that in their energy and carbon strategy. And clearly, I was inspired by some of the efforts that were done back in 2005 with Governor Schwarzenegger's executive order, and 2006 with AB 32, which created ambitious reduction goals for carbon emissions for the state of California, which has now been mirrored and adopted by many other states, which has helped to inspire other things, even within the state. You know, particularly SB 100, which was a California Senate bill, which has set a goal of achieving zero emissions from electrical utility providers by the year 2045. And so that certainly adds another arrow in the quiver for how we address carbon neutrality, and we'll certainly be talking about that a little bit. And particularly with healthcare, we do have this unique intersection between community and patient health. We do now understand that the emissions that are created in our community and in our environment directly affect organizations like healthcare organizations. And understanding that unique intersection has been really important for healthcare organizations, particularly the University of California. We also can't ignore what we're already seeing as the impacts of climate change and how that affects our communities, particularly with the wildfires. This year, as you all know, we're seeing unprecedented effects of that. And we've now come to understand that that is likely to be the new normal. And we really need to figure out ways that we can address our operations, particularly for organizations like the University of California, and supporting that. Also, when you're talking about healthcare organizations, there's some really specific considerations, particularly when we're talking about infection control. That's been one of the challenges for healthcare organizations in addressing energy efficiency, and how we can still provide patient care and also protecting the community at large. With the current situation we're dealing with the pandemic, that also further highlights the importance of understanding that intersection between community health and patient health, and there's going to be some interesting challenges and considerations we're going to be dealing with moving forward as we want to protect our community from pandemics, but also protect the community from the effects of climate change. And also, you know, healthcare organizations have unique process loads with how we provide that patient care. And then also some additional considerations of resiliency. In the event of a natural disaster, we want to make sure that a hospital is at least able to endure that. So I'm going to hand it off to Dan to give a little bit of background on UC Davis Health.
Hello. So the UC Davis Health organization serves a large area, essentially most of Northern California, which should be the area north of San Francisco up into the Central Valley, 65,000 square miles and over 6 million residents. We have facilities all over Northern California, primarily in Sacramento County, but a few in facilities in the other areas, which allows us to serve about 1 million people a year come to our facilities, with 30,000 coming to the main hospital and staying over. So we have a very large area that we serve, and at the main campus, which is really where we emit most of our emissions, we have about 142 acres, and we have about 4 million square feet of facilities, which would include the hospital towers, research labs, medical education facilities, and office buildings. And like any organization that's growing, which we are, you know, the demand for healthcare is growing in this country. We always have expansion modifications and decommissioning projects going on. And a few of the highlights for us are Aggie Square, which is about a 1 million square foot public-private partnership on the edge of campus, which will have medical education, student housing, commercial space, office space. That will be powered off the electrical grid from the local utility. That's basically a purely electric project. We have the big one for us that will be affecting our cogeneration plant is the replacement hospital tower, which is a 5 to 7 year project out in about 5 to 7 years, approximately could be upwards of 1 million square feet, and would put a significant load on our system. And then we have we have just ongoing upgrades at our central plant to accommodate these things.
Great. So thanks for that overview, Dan. So you know, as Dan mentioned, you know, there have been several master plans over the past 5 years from UC Davis Health, which are currently being updated. But as Dan mentioned, there's a pretty significant amount of square footage that is going to be added to the main Sacramento campus, as well as some of the other satellite campuses as UC Davis Health expands its service to the broader community in Northern California. And so it's important for us to understand what those impacts are going to be. One of the things that we helped UC Davis do at LeapStep is develop an energy carbon strategy, which is helping to develop energy targets for new projects, identifying opportunities for existing buildings, and then also looking at the opportunities with renewables and also renewable energy credits and offsets. You know, certainly we want to try to prioritize energy efficiency and carbon emissions reduction targets for new projects, because that's the best opportunity, because we have the opportunity to start from the beginning. But then also understanding the fact that given the energy intensity of healthcare facilities, it is very unlikely to be able to cover that all with energy efficiency and even on-site renewables. And so there's many things that UC Davis Health and the broader University of California Office of the President has been working on with respect to offsets, you know, particularly on the UC Davis Health campus, looking at biogas contracts to offset the cogen plant, which Dan's going to talk about a little bit later. But then also looking at developing a energy metering project or program to have a better handle on the actual energy consumption of individual buildings. One of the challenges of larger campuses is that it's not always easy to have individual metering of the individual buildings based on the way that the campus is grown. And so that's something that UC Davis Health is taking on to have a better view of the performance of the buildings and identifying the results of planned projects and initiatives. So as part of that, we helped develop a carbon dashboard for the UC Davis Health campus. This is not meant to be a tracking dashboard. It's really meant to be able to look at different scenarios, looking at the effects of the EUI targets or energy performance targets for new projects, but also evaluating the effects of different renewable energy systems and offsets. So it's a complementary dashboard to some of the broader things that the UC system is doing to be able to track their emissions, but it's really helping to provide visibility in the effects of different decisions for affecting carbon emissions. So Dan, hand it off to you to give a little overview of the cogen plant.
Yeah, thank you. So while we have facilities all over Northern California, most of those receive electricity and a little bit of natural gas from PG&E. We found many ways to offset that, especially as Arash mentioned, for future projects using the carbon dashboard. We're primarily looking at electrification, but our real big nut to crack is our cogen plant, which is really the bulk of our current emissions. Upwards of 90% of the emissions are coming from the cogen plant. So just a real brief overview of a cogen plant. In our case, it's about 28 megawatts. We bring in natural gas that runs a gas turbine engine, something like you'd see on the side of a military transport plane. That turbine spins a generator, which creates electricity. The heat off that produces steam, and the steam then is used to fire another or operate another steam turbine, which gives us a little more electricity. And then that remaining steam is used to produce hot water to serve the buildings, as well as chill water through absorption chillers. And then some direct steam going out to the buildings we use for sterilization and research in the hospital space. So we have this cogen plant that produces all our emissions, but also produces very inexpensive power. We run power costs are 3 to 5 cents a kilowatt hour, 24/7. Doesn't matter when we use it or when we produce it, it's cheap. So that's one of the issues. The other issue is that being a hospital, and we're the trauma center, the main trauma center for Northern California, we need to be up and running all the time. So our cogen plant is backed 100% by the local utility. in such a way that if we have an outage in our cogen plant, we have immediate power coming from the utility. If that goes down, then we have a large diesel generator bank also. So we have, in some cases, you could say triple redundancy to ensure that we can provide the service that our patients and customers in the area need. So that's one of the real challenges as we go to decarbonization, is how do we address that? So in the near term, what we're looking at doing is preparing for some of these options that many people are considering. And as Arash mentioned, is really looking at like how the buildings are performing. We have a very aggressive activity in the UC system, and now starting out here at the Sacramento campus, RESH commissioning activities and energy conservation measures. Also looking at how the distribution system operates, the piping systems that get the chilled and hot water from the plant, and then how the building profiles are. So we need to address that in concurrence with looking at how we're going to adjust the plant in the future. And part of that would be looking at things like heat recovery chillers, which operate at a much lower hot water temperature than our current distribution system. And we currently distribute water with 100-degree delta T. We'd be looking at a 40-degree delta T, and what that does to our distribution system is huge. So those are some of the things we have to be looking at as we go forward.
Great, thanks so much, Dan. Just going to go through this fairly quickly, leave ample time for the other speakers. So again, one of the challenges is portfolio growth. So focusing on energy efficiency for new buildings by creating energy performance targets, but also carbon emissions targets. Understanding that all energy isn't created equal, focusing on clean energy. Dan, you want to quickly cover energy sources? Certainly, you already talked about natural gas, but also the idea about electrification, trying to prioritize that for new projects so we can make that transition. You want to speak a little bit about resiliency, Dan?
Thank you. As I mentioned before, the triple power resources we have for electricity is critical to provide the services. So resiliency, we had the rolling brownouts just a few weeks ago. We were not affected by that. Actually, we were producing excess power to provide to the grid. So it's real critical that we have that available to provide services, because when people are injured or hurting, they want to be helped right away, and we can't have a hospital down in the area.
Right. So yeah, just close it off and cap it off and hand it off to our next speaker. Certainly understanding that there needs to be a transition plan for what's currently going on with the cogen plant, but also thinking about the fact that it needs to be a dynamic strategy, and understanding that what we can plan for today will need to be adjusted based on changes that happen in the future. So with that, I think that closes our portion of the session, and we'll hand it off to the next speaker.
Thanks, guys. Good stuff. It's you definitely have some challenges that others don't have. So we'll have some questions for you afterwards. So I'll ask those guys to get their webcams and audio on.
Great. This is John Elliott. Can you hear me?
Yep, you're good.
Good. And I'm here with my colleague Raphael Vitti today, and we'll be sharing some initial progress and thoughts about electrification on the ground at our site, Lawrence Berkeley National Laboratory, or Berkeley Lab. We're an Office of Science, a DOE Office of Science National Laboratory that's run by the University of California. And our main site is in the Berkeley Hills above the UC Berkeley campus. And we have about 2.5 million square feet of built space there on about 200 acres. Before we get into some details, I wanted to articulate at a high level what really motivated me to shift from a typical energy efficiency professional's view that certain loads should be served by natural gas to being fully committed to electrification. And that's that to hit our California state climate targets, are really any economy-wide greenhouse gas mitigation target that's oriented around limiting warming to 2 degrees C, requires 3 big things. It requires a whole bunch of efficiency, more than we've ever done, a lot of renewables, fully decarbonizing the grid. And if you just do those 2, you miss the target by a wide margin. So you have to do electrification where you're moving loads from fuels over onto that decarbonized grid. So here is one picture demonstrating a technically feasible path. This is done by researchers here at the lab, Max Way and others. And you see on the left-hand side, there's a reference case. So that's where we would end up in 2050 if we did sort of business as usual and current trends continued. And then on the far right, you see a compliant case where you've done everything you need to hit the target. And this is, as you know, these are ambitious targets. This is less than 1/10 the greenhouse gas emissions per person over a generation. So each one of these colored stack bars is getting you towards that goal. So the first two are efficiency and renewables, and that gets you about 2/3 of the way there. And then the next big pieces are heating electrification, or electrification in buildings, what we're talking about today, vehicle electrification, EVs. And then in this study, the last part of it was done through low greenhouse gas biofuels and also changes in behavior. I put the reference down below and also to another great paper, the one that actually influenced me to make a change in the work that I was doing. It's a science article from 2012 that tells the same story about needing to do efficiency, renewables, and electrification. So I'll pass it off to Raph now to talk some about the retrofit side.
Thank you. Yeah, and first of all, I wanted to look at some numbers in terms of the footprint of the energy that we're using for our buildings. So on the left, we can see the footprint as it was in 2017 for 1 MWh of electricity and 1 MWh of natural gas getting to our site. We can see that with the current energy mix in California, the footprint is 0.24 metric tons of CO2 equivalent per megawatt hour. For natural gas, it's about 0.21 when you include combustion and the losses during transportation. We also know that there is some upstream gas leakage that's sometimes not accounted for. That's from venting and flaring at the wells, so way upstream. And so just as an indication, I added up 1% of gas leakage upstream before it gets to California. We can see the impact of that both in the electricity, because back in 2017, we still had about 30% of our energy mix coming from natural gas powered plants. And so the main point there is that electricity is getting cleaner in California, and we're counting on it getting even cleaner. Currently, when the energy gets to the site, it's still a tiny bit dirtier than natural gas, but it's getting better. Now, what we do with that energy really matters. So on the right side, I applied some typical process efficiencies so we can compare the footprint of some of our end uses. And here we can see conventional gas boilers and condensing gas boilers for 1 megawatt hour of heating output are still a little dirtier than anything else we can do with electricity. And in particular, on the very right side of that right graph, you can see with a heat pump with a COP of 3, we get down to a footprint of 0.09 metric tons of CO2 equivalent per heating megawatt hour. So electrifying our heating load is already better with the 2017 California energy mix in terms of greenhouse gas footprint, and it can only get better. It's going to get better, whereas for natural gas, there's a natural floor from the combustion of natural gas, which is at 0.18 metric tons of CO2 equivalent per megawatt hour. So these arrows here represent what we're hoping will happen in the next 20 to 30 years. John, you can go to the next.
So we have been taking some steps on the ground with electrification in new construction. New construction is a slow process, so we've just gotten through one complete cycle of designing and occupying a building. So we occupied a 81,000 square foot genomics laboratory in the fall of last year that has fully electrified space and water heating. And we're also making our way through the design. We just completed construction documents on another 70,000 square foot laboratory that's also electrified in that way. So these are both using heat recovery chillers from the chilled water return on the cooling side with air source heat pump backup. So using heat pump technology. We also have another building in process, which is a multi-purpose facility. Notably, it's a replacement for our cafeteria. So we'll have an all-electric commercial kitchen in addition to the mechanical system. So I think we've really been able to standardize on electric new construction. And now we'll actually move to the retrofit side, which I mentioned earlier.
So here are 10 of our largest heating hot water plants on campus. We don't have a central plant. We typically have boilers in each one of our buildings. So here 10 buildings that represent about 41% of our current total natural gas consumption, which on this graph is showed in blue. As you can see, for some of these buildings, we've already improved, we've already implemented energy efficiency improvements. So at building 6 and 67 in particular, our consumption has already reduced quite a bit. We are pursuing further efficiency improvements shown in orange. And then once we get there and start working on converting to heat pump heating, we'll get a really large reduction and then get to the green bar. So the improvements we've already done compared to 2015, that represents a reduction in consumption of about 20% campus-wide. Our EUI, our natural gas EUI has decreased 25%. With the additional efficiency improvements that we want to do on these 10 plants, that would bring that number, the consumption number, down another 4% campus-wide for working on these 10 plants. And then converting to heat pump heating would reduce that another 19% for a total of 43% reduction of our natural gas consumption on campus. So this shows that we both need to do efficiency improvements and conversions and electrification of our heating. Can you go to the next slide, John? Thank you. So now some challenges we're running into that motivate the need for additional efficiency improvement. First of all, it's the cost of energy and equipment for electrification. So heat pumps are a little more expensive than conventional or even condensing boilers. And then the cost of energy for most people in California, even with a COP of 3, for a given amount of heat you produce, the energy consumed by a heat pump would still cost more than the energy consumed by a boiler. It's not the case for us because we have access to relatively cheap electricity. Another challenge that we're running into is the equipment footprint. Boiler is a relatively simple piece of equipment. Heat pumps use a refrigeration cycle, so they have a compressor, they have two heat exchangers. And so at the bottom here, as an illustration, I'm comparing with equipment we currently have on site, an existing condensing boiler and an existing heat pump we have in one of our new buildings, what it would take to convert one of these boilers to heat pumps. The footprint is about 9 or 10 times greater. And so in a retrofit application, that's a big issue that we have to address. And we address it in particular by increasing the efficiency of our system so we don't need as high of a peak load. Another issue is system temperatures. In existing systems, we have target heating temperatures of 150, 160, 180 degrees Fahrenheit. These are achievable with some heat pumps, but typically they come with a penalty to our efficiency. And so it's probably best to try and operate our systems at lower heating temperatures, which means potentially having to replace coils or having to make other changes to the existing systems. The fourth issue is refrigerants. All the heat pumps, since they use refrigeration cycles, they need refrigerants, and those refrigerants have typically a great global warming potential. And so we have to account for that as well as we go through those conversions. And the final thing we have to consider is sources and sinks For heat pumps need a source of heat to procure heating. So that's either air, but that comes with some efficiency penalties, or if we want to take advantage of synergies in our systems, we might want to reject our heat in an existing cooling water system, but then we need to balance those loads. So there's some additional complexity in trying to capture these synergies. And
guys, we got to wrap up to save some questions. Is that it?
That's it.
Oh, perfect. Really good stuff. So I would ask all the presenters now to just turn your webcams on. And I've assigned in the questions section, there's some great questions. I've assigned you each some questions. If you can take a look, because I don't know that we're going to be able to get to all of them. And I'm just going to throw up there, let me see. I'm going to throw up there just the speaker slide. So I'm going to start with a question for Google. Rolf, can you tell us what Google is thinking about as far as large campuses and employees working remotely? Quick answer to that question.
Question. At this point, we do have a big task force kind of reimagining what we are going to do with all of our real estate, you know, in a ongoing COVID and then a post-COVID world. There's no question that we're obviously going to continue to have a very large corporate footprint, but I think we're going to be repurposing that in lots of different ways. I think this enables us to have a lot of employees working from home, but turn our buildings more into a collaborative space and having people optionally come in and be able to work, you know, in close collaboration with each other. Hard to say what's going to happen in the long term, though.
Yeah, I think we're all wondering the same thing. Great. Dan Mendonsa, can you just mention that there's a question about whether you've considered biogas or green gas for your cogen, and can you just talk to that point briefly? You're still muted, I think.
Thank you. As was mentioned earlier, our Office of the President is pursuing getting biogas at 40% by 2025 for all of the UC campuses. So that's our first source. And we've been actively working with other folks to get the other 60%. So there's a cost, and so we're having to do some real analysis associated with that. But yes, we've have definitely looked into 100% biogas.
Great. Okay, good. And for Berkeley Lab, can you guys just talk to you mentioned heat pumps a lot. There's a couple questions about them. I'm assuming you're referring to water to some sort of water source heat pump, or is it air source? And then they're asking whether you have any ground source. And you can see the question, but how does it compare different types of heat pumps and what you're looking at there?
Yeah, certainly. Yep. In general, you can go ahead, Raph.
Go ahead.
Okay, yeah, so we are not talking about ground source heat pumps. We haven't done any of that. We have a very complicated subsurface environment at the lab. And then, as Raph alluded, in general, you do get efficiency improvements. So we are looking in our buildings to find concurrent heating and cooling and using heat recovery chillers in these two key buildings. But then you always have the option of doing an air source heat pump as needed to make up any other load. So that's generally what we're talking about, water and air sourced heat pump above the ground.
Okay, great. And then there's a question for, let's see, we got one for Google. Can you talk about as a for-profit enterprise, what's the competitive advantage of decarbonization, and is there a premium that you're paying for it?
Well, that's kind of a lofty question, but I'd say the competitive advantage is, first of all, if we don't have a sustainable way of operating our business, there won't be a planet in the long run to have it. So it is, to our advantage to continue to decarbonize wherever we can, to make sure that we're doing all we can to mitigate the impacts of climate change. I think Google also has been very mindful of its carbon footprint, even since the very, very early days, and it's been part of the DNA of the company all along to keep our carbon footprint low and eliminate wherever possible. So whether this is something that is a bottom line cost to the business that's sustainable in the long run, yeah, I think that the answer is absolutely. And it's a huge priority for Google.
Great. Okay, we've only got 1 minute left. If you guys have any other answers you want to give, you can type those into the questions box for everyone. But I do want to throw out one more, and this is to UC Davis Health again. What approach are you using to set your EUI targets for your facilities?
Dan, I think I can take that on. So it's been a combination of doing some benchmarking and baselining, looking at best practices across the country. There's the Energy Star database, as well as the ASHE Energy to Care database, which shows the performance of the healthcare facilities across the country. Obviously, it's important to look at the differences between unique facilities, particularly academic healthcare centers, and so making sure that there's an apples-to-apples comparison. So it's a combination of looking at industry benchmarks, looking at the databases, but also looking at industry best practices. Knowing that, especially in California, healthcare facilities can take up to 8 to 10 years to be constructed. We want to be tracking some of the best practices of projects that are recently completed and in process, to make sure that we're incorporating those, and then doing some energy modeling to be able to look at what is possible based on the current code and the current performance of some of the best practicing facilities based on cost-effective technologies.